someone has just pointed out that I forgot to turn the microphone on. Thank you. And we need to make sure that I turn on this one as well. Okay. That should be better now. And get the stream manager up so I can see chat messages. Righto. Welcome along, folks. Howdy, Andy Magic Knight, Gitkanan, and whoever the third one is who is lurking. So today we're going to take a break from doing the contortion of floppy drives and work on things ready for the release of the MEGA65. So trends are getting ready to make all of the other machines up ready, of that first batch. So the PCBs had already been manufactured some time back, but without any components on them. They've now put components on the first 3 of them, which is great. The problem that they're having is that the 3. Now you're saying 3 viewers or 3 machines? So they've, yeah, sorry, only 1,397 to go. Exactly, that's right. Well, you know, like the Smurfs in the factory can only assemble so quickly, right? The main FPGA is quite heavy for them to carry across the board. No, so what this is, so they do typically for us in the past 3 test units. So there were 3 revision 1 boards, then there were 3 revision 2 boards for initial testing, 3 revision 3 boards, one of which is here with me in the land of Oz. And if I go right, okay, so as you've seen before, my revision 3 board, so this is one of the very first 3 that were produced. In actual fact, sorry, yeah, the dev kits have got the revision 3 board, right? So then there were 100 more made. Yeah, that's right. The we'll get you pictures. Kitchen saying it must be hard to get the hamsters inside the FPGA too, as well. So yes, this is quite the high pressure hamster injection unit. This is a fine piece of German engineering. We'd show you a picture, but then we'd have to kill you. So anyway, so the revision 3A board, which will be just like this, but with one important difference, which is what I was busy trying to show before I realized and had drawn to my attention rather that the sound hadn't been turned on. If we go back to the MEGA65, so this is the flash menu, right? And actually what I should do, I've got the CRT emulation on again, which looks a bit cruddy. I'll turn it off in a minute for the stream. The flash on the MEGA65 board at the moment is a 32 megabyte flash chip. And on the older boards that had the A100T FPGA, pardon me, that was enough to fit 8 slots in, 8-bit streams. But with the 200T, the bit streams are twice as big, we only fit half as many, which is a bit annoying because 0 is used up by the factory core for recovery. Slot 1 is normally where you would put your updated MEGA65 core. So that only leaves slots 2 and 3 for it to be other machines. So, you know, you could put a Game Boy and Spectrum. They're the 2 other cores that have been made available by folks for the MEGA65 at the moment, but we know full well that there's an Amiga core coming. And there'll probably be a high compatibility oriented C64 core at some point as well. And that's annoying because you might like to have all of those things. And other ones as well that of Mr. Cores that will be ported using the framework that the guys who have done these other cores are making. So on these new revision 3A boards, they are putting a double-sized flash chip. So we'll go back to having 8 slots. So there'll be 64 megabytes of flash, and that just sounds like a good number anyway to have. And we'll have twice as many slots here in the the flash menu. Now, yeah, Animatic not saying ST core surely. Yeah, I'm quite sure that we will. Just hang on a second, think. Caleb is at the door. Okay, back again. Yeah, that's right. Andy Magic Knight says the ST core for both of the ST fans. Exactly. And then Kikanan says, "Hey, now I'm one of the two of them." Well, that's right. We only have to find the other one, right, and buy them off so that they don't need to have the SD core, and then we'll save some work. Not really. It would actually be really great to have a bunch of these different cores available. So, the problem that Trends have encountered is that the Xilinx tools are refusing to flash this big flash chip. No one knows why. It just is. So what they were thinking is, well, why don't we just actually use the MEGA65 flash menu to directly flash the machine. Now there is a secret keyboard sequence that you need to do in the flash menu if you want to flash slot 0. What I might do as well is I might modify that process so that it can try and detect if there's nothing in slot 0, and then it will just automatically let you try and flash slot 0, because we need to try and make the process as fast and easy for Trends as possible, because it's costing them labor, and that puts pressure on the price of the machine. Yeah, so this morning what we're going to try and do is have a look at, well, make sure first of all that we can flash the flash using a bit stream pushed in by JTAG, because there will be no core in there, so they'll plug a JTAG adapter in, and they will use something like the M65 tool to push a bit stream across, and then they will instruct the machine to flash itself, and so we want to automate all of this. Hey Prowl7, and also welcome to the other 5 people who are lurking there in the depths without having said hello in the chat. So that's what we're going to attack this morning, and there's also some other test bits and pieces that they want so that they can test every feature of the machine more easily. So I need to dig up, because we did have a test framework for them, and so I might just need to munge all of that together with all the different things. So over the last couple of days I've given them an Ethernet test, so basically tries to do a DHCP request. Hey Rafi, welcome along. So yeah, that's what we're going to attack. So first up, let's do, I will push a bit stream via JTAG, because there are some different things in the way that the FPGA behaves based on whether or not it's started from JTAG or whether it's started from flash. So from JTAG you can't tell it to restart again from the flash. There's something weird that goes on with that. But I think we can flash, and so we'll find out whether we can do that with a bit of a test. So we need I need to bin bit to core. Okay. So I'm just going to recompile the bit to core program. Just typing this off screen because it's just a little bit that I need to do on that. Bit to core bin MEGA65R3.bit. I have to remember what the options at once are. Bit to core, I do tell it the target. MEGA65R3. and then I need to tell it the core name, so that will be MEGA65 R3 dev core 2021. I'll put the date in 1030 because that's always a good thing to have in there. Oh, that's just a core version that can go underneath. Dev, and then the out.core MEGA65 R3.core, and it's complaining to me. Target, yeah, because I need to give it the bit file. That would be really helpful. Bin MEGA65 R3.bit. Right, okay, so now I should have a core file, and I will use MEGA65 FTP. Now you start to see some action. Put MEGA65 R3.core to MEGA65 R3.core. Right, bloop, 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 loading. So this will take a little while because the core file is fairly big, and the MEGA65 FTP program is pushing via the serial monitor interface. Yeah, I need a listen. So what I need to have a listen command, I need someone to give me really quick, easy instructions to set up something on Linux that lets me see and interact with the Twitch chat thing. I know it's possible. I just haven't had the time to figure out how to get all of that set up. So if someone can provide me with all of that, that would be fantastic. Because then, yeah, we can do that. Okay, so that should have gone through. So now what we need to do is, so I'm going to hold down the no scroll key while I push a bit stream via JTAG. So this should come up directly into here. Right, and so this is the message that I built into the thing. So it means that you can't use this menu to launch other cores, but you will still be able to flash new bit streams. And that's what we want to be able to do. So we want to verify that we can do that. Right, so this is when I do the secret Vulkan nerve pinch on here. And I have to remember the sequence of actions here. So it makes you type a whole pile of really annoying. So this is not going to be good for trends, right? So I'm actually not even going to go any further. But it's a bit of an Indiana Jones style get through all of the barriers before it will even let you try and brick your machine. Because if you do this yourself and you screw up what you're flashing, you can brick the MEGA65. And I'm actually just going to, before we go any further, turn off the CRT emulation so this doesn't look so crusty. Why is it? It was saying off. Okay. It was claiming it was already off when it was clearly on. Anyway, there's probably a bug there we need to track down at some point. Cool, but so that it's just on the stream that you get that Moira effect otherwise from the CRT thing with the scaling. Right, so we need to make a version of the MEGA65 flash program that will let trends super easy flash a core into slot 0. Righto, so now we need HDMI here so that I can do the development. And blop, 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 blop. Right. There we go. And then I need to do that so I can actually read the text. That's hopefully large enough that everyone can read. Source utils mega flash .c. Reload, yes. Okay, so this is our flash utility. So we're going to make a copy of this. I'm just going to call it JTAG flash. Right, and I'm very briefly, I just need to disconnect that display because I'm going to I don't want to show people the correct answers to the questions you get asked when you try and flash slot 0, because we don't want people bricking their machines. So I'll just do that off screen. Right. So we want this to be super simple. Now you have to remember how this all works, right? Because I haven't messed with it for a while. There's a bunch of stuff that we don't show because it's clutters the screen up and makes the program too big. So that the flash menu, when it runs, actually runs in a special memory context in boot, and only the lower 32K of RAM is available in that mode because the hypervisor is taking the top 32K. But for trends, we want to have all of this gory detail visible. That was me testing things. We'll clear the screen at the beginning, not at the after printing all of this stuff. Okay, we don't want that, so I'm just removing a whole pile of junk. Right, so the tab key or no scroll Bucky held forces the menu to appear. Okay, I've sort of forgotten that we had it set up to allow the tab key instead of no scroll, but that's fine. Okay, so we're taking out all the stuff that switches to bit stream. Right, now we're getting to things. Yeah, we don't even need that. That's the stuff that works out whether the FPGA has been booted before. Okay, prune out more of the rubbish. Yeah, we'll get rid of that message because we don't need to have that message. Okay, and so now we're getting down to our menu. We don't need to display the menu. Launch, no, we want... Oh, that's right, I forgot we have that M key. You can actually inspect the flash memory from in there. Right, we want always. To refresh that. Yeah, Keith Cannon says if someone really wants to brick their machine, it's not hard to find the source in GitHub. This is true, but yeah, that still makes it an extra step for them to have to do. Yeah, it's just the kind of person who's likely to brick their machine and get really cross about it isn't likely to look in GitHub. Right, so we're just responding to, because we're in contact with the team in Germany at the moment. Blah, 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 yeah. Right. Back and forth with that. Okay, so yeah, so we can actually we can simplify this even further. It's just reflash slot 0. Now what we want to do as well okay, we have our progress bar. We'll keep our progress bar. We have the disk chooser. Okay, so this should bring up the... I think what I've done so far, it should just bring up the disk chooser and just ask us for a core automatically. But what we need... Right, we need to fork this one. Hey, Laden23, welcome along. Good to have you there. Let's get the commands here right. Now we don't have to have this size test because this one is not running in that funny context. I think I've got rid of all the size conditional stuff out here. Hey Anton and Deft, welcome along as well. Good to see yous. So we should be able to. Yeah, let's go. JTAG flash.prog. No, where did I? Where's it going? util.d. Okay, right. Yeah. Oh, cool, okay. M65-B, no, F for run source utils JTAG flash prog. Okay, so Detlef was just asking me off screen, saying, oh, I need to be able to know how to do the secret flash of slot 0. So that's what we're actually solving with this new JTAG flash utility. So this will be a standalone program that Trends will be able to run that will let them do that. So I need to find out why that's not working there at the minute. Probing a carriage return there would be helpful for our formatting, and I need to fix the text color as well. And it would help if I actually showed you what I was looking at. Okay. So we're well on our way. Now I have to find out why it can't. Oops. So we're trying to read it. It's been a while since I've dived into all of this junk. So this is doing, it's SPI based flash, so it's communicating on the SPI port. Now what's curious, right, is we know that when we, from this JTAG pushed bit stream, we jolly well could talk to the flash. So I've chopped something out that I shouldn't have. Did I chop that one out? It's entirely possible that I did. No, okay, so I have got it in there. Okay, so it's not that. What other likely things have we got there? Let's look at it side by side. Okay. Time to play spot the differences. Start by resetting CS high. Okay, yep, we've got to disable all of that. That's all looking It's gonna run it again. Whether it's some weird thing with there's some delay that needs to be in there. Or is it that it has to be in hypervisor mode to be able to talk to the flash? It's possible that I've gone and got all clever pants and protected the flash. So we've got another off-screen message here. Okay. Yes, right here, Leiden says, protecting the flash from smart Alec MEGA65 users would be wise. Yes, and I believe that I had that wisdom. Okay, so let's have a look at here's our QSPI stuff, so we can read them. That's good. Ha 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 ha. Ha ha. The QSPI clock is stopped when you're not in hypervisor mode. And in hypervisor, if you're not in the hypervisor mode, then you can't set the lines. So yes, I have indeed. Hey Herdware, I have indeed sort this thing out. Yeah. Right. So we need to have some nice mechanism that lets us have at least, I mean, it's an engineering mode bit stream, right? That will let trends do this super easily. So I just need to think about the right way to do this, because I mean, I can make a one-off bit stream that will do it, and that might well be the case, but I would like to have it so that it's easy enough for us to do that. And welcome to everyone else that's come on and looking. We've got 16 tuning in at the moment, which is great. So welcome to everyone who's lurking in the background. How shall I do this? I could possibly make it so that one of the dip switches on the motherboard will do it. So Leiden is saying, can you do some sort of preprocessor stuff to enable it with a makefile var? In VHDL it's not quite that easy. You can pass generics in and do it that way. But you know, I'm inclined to make it so that one of the the dip switches on the board. Where's my? I forget which camera number is which, right? If we have a look in here, right, and here we have the insides of the MEGA65, and over here, a little bit hard to see. There are 4 little dip switches, and we don't really do a great deal with them, but I think this is probably a good use for them. So that there'll basically be an engineering mode that unwrite protects the QSPI flash, and if some fool has opened the case and set that dip switch so that they can whittle all over their flash and brick the machine, well, that's their own problem, and they then clearly know where to find the JTAG adapter connector and start trying to solve things. So yes, so let's do that. Okay. And as life would have it in great fortune, we have the dip switches fed into this same module already. So that's D69D. I just need to double check that we don't do anything with them. Anywhere else. Right, so D69D is not used in there. Oh, hang on. Yeah, I did do it the right way, didn't I? Yep. Oh, I've got funky logs here. Right. This would be a smarter way to do it. So nothing there worries me. That all looks, well, it's scrolled off the screen, right? Nothing there. Nothing there. Okay. So FFD369D, that's our dip switch register. So if we can look at that, and I can set switch 1 blip across to the other position, and it gets set. Sweet. Okay, right, so dip switch 1, I'm not sure, It's just reminded me, dip switch 1, and I knew something was using the dip switches. That connects the keyboard to one of the JTAG adapters for flashing, so dip switch 1 would be a bad dip switch to use. Dip switch 2 has just done something with the video mode. Dip switch 3 looks to not be used. Dip switch 4 looks not to be used. Okay, good thing we're checking this stuff, right? Oh, look at that, and Leiden's busy looking at the VHDL for me. Yeah, so dip switch 1. Oh, that's right. Yeah, so yes, if you set dip switch 1, it disables the audio on the digital video output. So you get pure DVI output. That's why the video was losing there for a minute. And that was the only dip switch wired up in there, I reckon. Let me decompose the display there. So there's our dip switches coming in. That's what Leiden was talking about. Def says, nice one, is that in the manual? I doubt it. It probably should be. If someone on the thing can file an issue against the manual to describe the dip switches, that would be great. Yeah, so we're talking about the dip switch there. Okay, let's just check the other dip switches. Oh, hang on, Caleb's at the door again. Oh, I should be back in 60 seconds. Okay, just averted a disaster with Minecraft not responding for Caleb. So all is good again. Okay, so that's what I was going to do. I was going to look for the dip switches. So the HDMI test is a separate target for testing, so that we can ignore. We're looking for things that do things. So the max 10 is driving the dip switches across. That's all fine. Where are we? Dip switch 2. Yeah, we've talked about dip switch 2. Okay, so there's nothing else there that worries me. R2 max 10. I thought the dip switches went to this directly. Oh, there they are. CPLD-CFG. Right, yep, so that's how they get passed across to the big FPGA. And that's the one that connects the keyboard, and okay, that's the only thing there is. Right, so we can unwinding from all of that. Now it's dip switch numbered 2 here, right? Because they're numbered 1 to 4 on the board, they're 0 to 3 in the VHDL. It's a QSPI, wasn't it? That's what we want. Here we go. Or, hey Maurice. Dip swip 2 is equal to 1. Oh, hang on. Are they? Sorry, just going to make sure that I have got this. How have we got? Oh, sneeze. Passing in 5 dip switches, which is most strange. What I'm going to do is I'm going to double check that the one that we want to switch is bit 2. So I'm going to slide it across and go, and 4 is set. So that is the correct one. So this should work. Okay. So MEGA65 core issues. So I'm just going to file an issue for this so that I can tag the commit. I'm just going to do this off screen because I can't be bothered getting the browser onto the right display there. Just make sure that we don't have allow access. Yes, that's done. Right, I'm just making sure that we haven't got a conflicting issue. So we've got issue 443. Anton has asked if we can have dip switches to select the default boot slot, which we'll be able to do. Oh, hang on. What's Detlef has just said something there. Ah, okay. So if you can fact check what is written about the dip switches in there, and bonus points if you want to update it in real time as we go through. That would be fabulous. So I'm just going to put a note here on this existing issue. This will need to be dip switch 4 because 1 to 3 are already used, i.e. allow selecting between only 2 different bit streams. And I might even actually fix that issue while we're here this morning as well, because that will be fairly easy to tackle. Right. Ah, I've gone hit the wrong button, haven't I? I've gone new issue instead of save. Comment. Okay, now I hit new issue. Dip switch 3 on equals allow access to QSPI flash from outside hypervisor. And I'll put a note here. This is required so that trends can use a modified Mega Flash JTAG flash program to provision the production MEGA65 machines. C also hash 443, as we now have all of the dip switches allocated. Submit issue. Right, assigned to myself. Milestones. I don't think we've got any milestones. No, we haven't got any. So I'll just label it as a bug. Because we haven't got the range of descriptions of things in there. So this is issue 464. Yeah, Edward says small dip switches, small. Yes, it is tiny. That's right. You know, I've got just a little tiny tool to slide it across, because you shouldn't need to fiddle with the dip switches all the time, right? So let's. So we've got that change in there. Git diff source VHDL. We're already in VHDL, right? VHDL SD card IO. Right, so here's our changes. Git commit. Allow QSPI access if dipswap 3 equals on hash 464. Okay. Git commit makefile and source utils JTAG flash.c. I need to add JTAG.c first as well. Begin working on JTAG flash util. Right. So let's go back into megaflash.c slot 1. So if we have a valid bitstream in slot 1, okay. So warning slot 1. Okay, so we just need to trace my way through the logic here again. Okay, so line 23 saying the dip switches are on the TO790. Only one line is about dip switch 1 and warns about the keyboard going into ambulance mode. Yeah, so we should actually have a separate, just a little piece on saying what the 4 dip switches on the MEGA65 main board does, and to have a table of them, and maybe a little picture inset showing where in the on the main board they are to be found, because the dip switch thing is small. So it's it's S3. Okay, so this is where we're checking if we can. Yes. Yeah, so this is where we check the flag. So what we want to do is auto boot address is equal to slot size times 1 plus peak OXD69D allow booting from slot 1, or if dip switch 4 is off, or slot 2 if dip switch 4 equals on hash 443. So then what we need to do here is say auto boot address and we'll update this message. So 1 plus peak OXD69D. Okay. So I think that should do the trick, and it'll give that meaningful message saying that the slot is messed up. Okay, let's just make sure that that hasn't made it too big. Yep, it would help if I created the variable that I'm now trying to use. What was it? It was auto boot address. Yes, that's good. That's fine. And let's make sure that the other one works as well. Okay, right. Git diff. I think this can all go in as one commit. Yep. Allow dip switch 4 to select between slot 1 or 2 on boot. Right. It's that happy sound of getting issues fixed. So Git command saying it might be good to reserve one of the dip switches for 15 kHz versus 31 kHz video output should that become possible. Yeah, it'd be nice. Hey LGB as well, welcome along. Unfortunately we've just used up the last of the dip switches. But I think as well that 15 kHz video will probably just be a different bit stream. So yes. I think that's the easiest way, is to just have a different bit stream for that. Or it will actually could be a config option, to be honest, that makes the VGA produce 15 kHz output. Oh, I know I've caused a flurry of activity on the manual channel on Discord, which is great. Just love you guys all just working cooperatively with us on the machine. So yeah. Cool, just making sure that that's all going fine. Okay, so we should now be able to set that bitstream building. So I'm going to do that off screen just so that I've got that terminal window there free still. McBit MEGA65 R3. Okay, so in theory that's now going to run for quite a while, like 3/4 of an hour. So what we can do in the meantime is we can look at the test program. So Trends need to have a test program that they can run on the machine that tests a bunch of stuff. Now, we made something like this. Here we are, R3 production test.prog. That's not what we want to see. We want to see this. Oops, there it is. So, what we need to do is improve this so that it does a few extra things. I'm going to merge this with one that actually does a DHCP address probe, and I think Detlef also wanted joysticks being probed. Let me have a look. So I want to test the IEC port. So joystick and IEC in there as well. Okay. So we should be able to do this. Oops, that's the wrong. I want this one. Okay. Blop, 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 blop. Now, what we need to do is is it M65? What did I say it was called? R3 production, that's right. So we don't want... Right, okay. So we need to copy paste a whole pile of this stuff across. Which is fine, we can do that. How's this structured? Let's just copy it all. And then we need to go to where I have the... We're going to merge this in to a test that we have in WIP. So Leiden is just saying... Oh, okay, so... Yep, sorry, so Detlef is saying, yep, test the joysticks as well. And how to test the IEC port. Yeah, we'll get to that in a moment. I think you're right that we can probably do something where we can short lines and basically just make sure that they work. That we can make up a thing that you plug into the IEC port that has some LEDs, and then basically get them to confirm that the LEDs all turn off, and basically the LEDs will blink. And then have it so that they can have buttons. They have to then press a button on each one that actually shorts the IEC line and confirms that that IEC line works for read. So that will be fine. Now we need source. What did I call that Ethernet test? I forgot. Was it just ETH test maybe? Yes, I believe it is. So I just need to think about the right way to do this. So Leiden is saying those appendixes are not in the user guide. Yep. So one question will be if those dip switches should be in the printed manual if yes, they need to go into a section of the user guide. Yes, I think raise that question on the manual channel, and yeah, talk it through with BitShifter as the keeper of the user guide to see. But we can certainly make an appendix that actually describes them to go into the full book, and then you've got the content there to be able to pull that out. Okay, so let me just double check that I have. Yep, we've responded to everything that's in there for the moment. Okay, so we need to get the right behavior here, because this block of code will do a DHCP thing, and I think we're just going to leave that as it is. So we will basically do the DHCP resolution first, and that has to succeed, otherwise we don't proceed with the rest of the tests. Is programmatically going to be the easiest way to do it. So I need to cut that out of there, and that all needs to go up here above main. This is just, the helper functions that we're calling from further down. So test 1, make sure Ethernet is working and can obtain a DHCP address, as this tests both sending and receiving, including that the packet contents haven't turned to custard along the way. Cool. So just in terms of talking about sending a joystick to them, you could make a joystick, or we could make up a little octopus device that has 2 DB9s on it and has an IEC port on it and has a bunch of LEDs and a bunch of switches, and have it instruct them to confirm that LED blah, basically flash the LEDs in sequence across, and then they basically confirm whether or not, or visually inspect that the LEDs are blinking their way across, and then basically have them press the switches in order as well. So they would just go, left to right, bloop, 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 across the switches, and it would pick each of those up and go, yes, life is good. That, I reckon, will be the fastest way for them to work. Yeah. And if you want to make it even faster for them, you'd actually put the 2 DB9s on a little PCB, so that you can actually, you just push the PCB into the 2 joystick ports together, because it's perfectly spaced. That will be faster than fiddling with 2 cords, because you'll have something really big and solid to be able to hang on to, right? If minimizing their time is the priority. And I'm just going to leave all of the other stuff in there to make our lives really simple. So this I need to change, because otherwise it's going to go perpetually in this. Oh, my back is a little bit sore this morning. The trouble is we need to find testing volunteers that live near trends, right? Which might be a possibility. I'm not sure who lives up that way, because they're not in what we would call a particularly heavily populated corner of Germany, if I remember. And it's probably going to be minutes per machine. So to do 400, it's going to be realistically the better part of a week of someone's time to do. So, but maybe there's someone in the community who's up for that. And I guess the other question is whether trends want that, or whether from an ISO 9001 quality perspective, whether that's more hassle than it's worth for them. So DHCP, I'm just going to find, yes, here we are. I knew I had a magic thing here where we can check the whether the DHCP is configured or not, and what we can do keep monitoring the network interface. The reason that I'm putting this in here to keep monitoring is that we can be able to respond to pings when we do this. Okay, so let's see if what I've made works. And we've got problems, right? We're actually just going to skip the whole double buffer thing, I think. Because in fact this actually does that. Because we don't need to have double buffering in this particular program. So the screen lives in the upper two banks of RAM. So we can just do that and activate double buffer. Yes, we don't even need to do that. We can just make the screen point plot pixel, because it's really just for this. So we're using the screen at 5,000. So we just need to move that to there, so that we're not having a separate copy at 4 in bank 4 and then in bank 5. We still have a call to activate double buffer. So that should be one less error. So now we've just got this TM stuff not defined. That's fine. Which I'm guessing will be because we haven't got one of these includes. And then I, A, and B. Okay, so A and B are just chars. This is nice and easy. Get my fingers right here. Error. Cannot generate most of the files. Yes. We're 3.4 kilobytes too big. Shmee. Probably because we're using printf. Somewhere. Yes. Look. Let's just try disabling. Oh, no, we're not going to be able to do that easily. Oh, sod. I really wanted just to have a single test program. But if we're putting these on a disk image, the other way around it would be to have one test run, and then have it load the next test automatically. That would be easier to do. Okay, undo all of that work. Let's make sure that it still works. Sweet. Oh, so it's done DHCP. So at this point, we want it to load a different file from the D81 image, and then we can put both of these on a D81. It's probably the easiest way. The other way would actually be to make them implement our test framework thing, and then that can just load them via M65. That might be easier for me to cook up in 5 minutes, I reckon. So we can have a look at tool source test. I don't know, some of these implement it and some don't. Oh yeah, we've got it in their unit test report. Bloop. So we need to include tests.h. Okay, and we have to do some funky stuff here, right, to set up the test. I think it's unit test, right? Okay, yep, so we do unit test report while I'm just going to call it issue 1, even though that's not right, that's fine. Indicate that DHCP succeeded. And then there's a magic thing at the end where we tell it that they're all done. Whoops. Okay, let's try that. Oh, that looks good. Now that I can't remember the, is it U for U? Ah, yeah, -U unit test mode. M65, so we can run it the same as we did before, but now we can add -U to it. And I'll composite it, so hopefully you'll be able to see that it will right. So entering the unit test mode. It's trying to do the DHCP, and it completes. So we can then have it load up the other program. And actually it'd be nice because we can actually then produce a test log for each board on that side, which I think is also kind of nice from a trends perspective as well. So let's, what have I changed here? Clearly I fixed something in there. Improve test. Oops. ETH test for trends. Now, what else have I got in here? Because I was busy changing stuff, removing some debug, right? The rest of that I think is fine, so we can leave that. Okay, so that's got us one of the programs. I'm just going to send that through off screen into our test procedure thing. So the guys have got it. And I'm just going to make a directory here. So R3B production testing. Okay, so we've got that in there. Good. Okay, so now we can go back to our R3 production test. So we should do the same in here. So we already have some IEC tests to make sure that the lines aren't stuck. Which is good, and we make sure that, so because of the way the IEC port works, you can actually test the loopback whether the pins actually work, because there's a separate line that goes out to pull a line low, and then you read it in on a separate line. So I think that if we actually don't need to plug anything onto the IEC port, the only thing it would tell us, and maybe there is still value, is if there was a dry solder joint on the connector. So let's, I'm going to add in the unit case stuff here. Right, and so it plays two different tones through the two speakers, and we'll come back to that after. Flag whether we can read the floppy. flag all of these as well. So that's this is a bit fiddly to. We can have tests that if you see nothing in it, well, no, we want to know that they've passed in the affirmative sense. So we'll put that in there, and so that's and then we've got this one as well. And we'll have the overall fail pass for this one. And I'm actually going to make it so we have a different test number for each subsystem so that we know broadly. So 2 will be Hyper RAM. Call it 3 and 1. And then these will be 4. I need to take 3 off of those as well. Right, okay, 4 and 1. Right, so that will be, oops, there needs to be 5 there, doesn't it? Oh, hang on, so Leiden's asking, so the keyboard switch I don't find in the core. So that's dip switch 1. And so if you switch it on, you will see the ambulance lights on the keyboard, and that enables flashing of the keyboard via the arrow JTAG adapter, so not the one that you would use to normally flash. Does that answer the question? If there's still outstanding questions on that, let me know. Yes, it's unchanged from R2, exactly. Yep. So the difference between the R2 and the R3 board is kind of mostly fix-ups. There's not massive changes. Uh, 5, 1, and this will be a pass. Whoops, pass has more S's than that. Okay, yeah, so 1 is the keyboard flash, 2 is no audio, 3 is QSPI flash enable, yep, and 4 is boot slot 1/2. Hang on a second, Caleb's back again. Thank you, Maurice. Yes, I forgot to turn the microphone back on. So this is going to repeat these tests somewhat. Because the real-time clock one, yeah, I'm going to change this because at the moment it basically tries to run these tests endlessly. So I'm going to disable that. And so if the real-time clock hasn't ticked yet, we want to try again. Hey, Andy. So is there still no sound, or the sound is back now? There should be sound again. Okay, cool. Yep, that's right. Right. Yeah, it was an old message. Yep, no drama. That's right. I just like to make sure. And try again. So we haven't got a long-term sleep function here, so we'll just do then the Ethernet controller. Again, we want to for A equals right. So we will. Well, actually, you know what? We can take the Ethernet controller test out because we will have only got to this point if the Ethernet is working. Don't test Ethernet as we test it in ETH test prog instead now. Right, okay. Unit test. Whoops. Oh, how did we do it? It was done all, that's right. And we were up to 5, but I'm going to call it 10. Right, make source tests R3. That's good. M65-UF4R. Look at that. Now, that's good. So we've got 2, 3, 4, and 5. So we need to add in and get them to actually confirm that they heard audio from the speaker. Ooh, and that sounds really annoying. I'll just turn on my speaker. I don't know whether you can quite hear that coming through. It's just two very annoying tones, one through each speaker, allegedly. So we'll need to test that. We also then need to do the joystick test. I'm just going to move to the HyperRAM probe, and because we've taken out the Ethernet test, we've got a gap in our thing. So I'm going to move up the Right, so that can come up one. Ah, yeah, so I need to fiddle this as well a bit, don't I? So we want for a, so I'll make it every half a second. It will change which speaker it's outputting from. Well, actually, no, we can get, we can just make them do it this way. So what I'm going to do is play a tone from one speaker, and then we'll play a tone from the other speaker, and in between we will ask them for confirmation. Move the order of these so that they actually reflect the display order, because it's a bit crazy with them the way they work. Okay, so this won't currently print the test result out. So Serato is asking, did you get to the bottom of the glitches in your floppy reading MFM decoding in the last stream? No, I haven't had a chance yet. I've been waylaid with this, and in between time actually getting disk image creation working in the freeze menu, which we might jump back to if we get if we're stuck waiting for bitstreams to build with this current stuff. But yeah, so it's still on my queue. It will still happen, just not yet. Okay, so let's okay, so I need to shorten that. Well, yep, and I can hear an annoying tone. And I can hear a tone there as well. So that works. And now I just need to tidy that all up. I'm going to make the tones much lower because they're really annoying. So let's do that. Because they're divisors, not multipliers. So we're now producing ultrasound. We'll try that. Oh, now Bitstream is nearly finished cooking as well. Right, so we've got that tone in that one. And then that tone on that one. They're still a bit annoying. Okay. No, I'm kind of bonkers here trying to get the sensible. Tones. So the left and right speaker applies to all of those speaker types. So let me. So the second tone sounds better than the other one. So what do we have? Let's try that. I just want it so that the tones aren't too annoying to listen to. But I think they're going to be annoying to listen to. It's a bit unavoidable. Short of getting much more fancy, like the old Sound Blaster test programs. Your speaker is working correctly. But it's only there for a second, so that's fine. Well, we can do a switch, right? Yeah, so then we should test those on separate lines, shouldn't we? Put ASCII codes in so that CC65 can't cause us grief here. Okay, so now we want to have our unit test report. Okay, let's try that. So if I say P for pass and F for fail, yes, they show up there. So now we just need to make it update the display as well, which is not too hard for us to do. We're doing 5, right? And because of the way we're printing, we just need to have blank characters there. And red for fail. Let's try that. So if I say pass, yep, and if I say fail, yep. Okay, give or take some rubbish appearing on the screen, which I can't be bothered debugging just at the moment, because we still get the general idea, and more importantly, whoops, we get the test report. So now we need to add in the joystick port testing. So these messages are a bit terse, but again, whoever's doing the testing will get the hang of this pretty quickly. So what we want them to do is to do left, right, up, down, fire in that order, and then we'll check the joystick ports values for that. Actually, we can do it this way, right? So we can do that while peak DC, it's DC01 I think, isn't it, joystick port? Is it DD01? I think it's DC, yep. Anti-Magic Knight says, how many fire buttons does the MEGA65 support? Though Shalon said it was 2. Yeah, so this is the one thing that I'm a bit annoyed that I didn't think about early enough with the board design, and so this won't be fixed for the production machines, at least not for the first batch. It might be that the second batch actually have it fixed, so there might be a bonus if you got it in the second batch. Is that the joystick ports are read-only. You can't drive a line load like you can on the C64 with its joystick ports. So joystick things that need to be able to select multiplexer lines on the joystick port to tell logic in the joystick which buttons to present don't currently work. Now, it's possible for us to make a crazy adapter that provides the clock for that externally at a fixed frequency that we can recognize in the MEGA65, and then we can have the MEGA65 do the demultiplexing automagically. So for the moment, yes. Realistically, you could make a 3-button joystick where it had the one normal button, and then the 2 pot lines were used as extra joystick buttons. That would be possible, but yeah. So there's ways and means in the long term to solve this, including with the initial batch. Right, if peak OXDC01 now I have to remember which order the bits go as well. Right, so there's that. I'm going to put a joystick in port 1. And it's this one. Right, so if I hold left, we should get FB. And then we will do the unit test report 7, 1, test fail. And we have to wait for the user to release. Now this is going to get repeated a number of times. So we're going to put this into a little function. We will do joy test port 1. It will be test 7. It will be thing 1. And we're expecting 1B. Test major, test minor. Haven't put in here yet. And then need actually that and that. Right, so we'll build our message that we want to print. We will do all of that. It's top of main, we'll put that in up here. Right, so we should have, oops, and let's get these values in here. 1, so we want to see, so now this is right, so right is F7. Up. E. Down. Whoops. I can type the address in. 1D. And then fire is 0F. And what were our, so need to change these. Okay, major, minor, port. Okay, yep. Major 2, 3, 4, 5. 2, 3, 4, 5. We need to actually use the right port. And then we need to fix display of the port. Now, of course, because the ports are backwards, right? So if it's So that should work for us. Let's see if that is going to work. Okay, so I can hear that tone. I can hear that tone. Push joystick port 1 left. Something is a bit bad there because it's operating too quickly and the joystick has glitched as I've plugged it in. So I'm really interested to see what the test results were there. And okay, we're still passing in the same minor test number to each one. Yes, we are. So that should be Maj and that should be Min. Because this is supposed to wait for joystick to go idle again. Probably what we need to do is allow a bit of debounce time. Okay, I've actually got two joysticks here. I can plug them both in at the same time. We'll try that all again. Leiden23 is saying that we need to check a value there. Yep, so this is quite likely true. Yes, because it's doing 2 at a time. Let me have a look and see where you spotted that. If, so not that if. Whereabouts are we seeing? So if we check that, while that's that, we wait for that. Okay, if the value we get is not, yes, we need to, yep. That will be the one you're talking about, yep. Or at least that'll be a problem. Okay, left. Oh, and it's still doing 2 at once. So we're getting every other one of those failing. So why is that? How is that happening? Let's just, shouldn't matter. But we'll put a idle check in at the beginning of it as well. Okay, left, right, up, down, fire. And I need to fix the pooping on the messages, right? Sweet, so now that all works, okay. So I just need to pad these all out to the same length and that will stop the pooping. pass. Okay. Left, right, up, down, fire. Left, right, up, down, fire. Cool. Stash changes here, haven't I? Okay. Now we should be able to do the pull rebase. And push. Okay. Oh, stretch. So what else do we need to put in the test there, Detlef? I think we still ideally want to have it so that we can test the IEC physical port rather than just the loopback. Yeah, so having the names in the tests, so Leiden is saying here, yep, absolutely agree, is a really nice thing. I'm just being a bit of a lazy bum. If you want to go through and add them, then that would be fabulous. And then, yeah, just update the binaries and chuck them, or just let me know when you've done it and I can update the binaries and push them through to the guys. That would be great, thank you. Because that will be a really nice improvement and make that test report much easier to read. So now, Detlef, do we want to also include the keyboard test in this program so it's all one go for them? Although de facto, the pass-fail for the sound actually requires the keyboard to be connected. And I guess that's another question as well. Do we want them to have to connect a keyboard for this test? I presume we still want them to actually test a keyboard, right? On there, otherwise the keyboard interface hasn't been tested. Assuming that you're still there, Def. I'm sure they are messaging off here. Okay, there you are. Yep, you're there. Cool. Yeah, so it might be good to find out from them what they want to do on that. Yep, yeah, please do find out, because I think we have a keyboard test, and okay, it means that they have to reboot again, but we have something. Whereas we don't yet have the ability to do the flashing. So yeah, I'm keen to switch back to that. I just need to take a 5-minute break, and then I will be back and we will attack the next things. So back in 5 minutes. Okay, catch us back in a few minutes. Okay, back again. So, we have that test program. I'm just going to push a copy across to the guys. Fine. There. Right. Blop, 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 blop. Okay. Right. So we are getting this sorted. And now what we can do is push our bit stream via JTAG. Okay, so Def is just saying that, yeah, GMK was doing the full keyboard testing. Yeah, I think you're probably right. I think it's reasonable. If they just have to press pass or fail with a keyboard attached in that test, that will just test exactly whether a keyboard is there and working. So, yeah, I think that will be fine. Yeah, it doesn't take long to attach the keyboard to the motherboard for testing anyway. So, okay, so we have that there. So now we want, that's what we're doing, for run source tests, utilities rather, JTAG flash.prog. Okay, now I haven't set the jumper yet, so I'm expecting that this will fail. So now if I set jumper 3, bloop, and we get ready and we run it again. Hopefully, look at that! Success! Cool. It's always nice when VHDL works the first time. So this will always just go on slot 0. So I'm actually just going to make it so that it doesn't just jump straight into there. I want it to actually show me the flash contents and the configuration first, because we probe it and then we call reflash. Okay. Why is that ignoring my keyboard check? Ah, I know why. It helps if you recompile the program if you want the changes to take effect. Okay, I think we should clean this up so it's easier to read. Device ID, sector architecture is 4 kilometer, parameter sectors with 64K, yep. 2 to the 8 byte page, erase time, flash size is 32 meg. That's kind of what we care about the most. Okay, so we can just tidy up a bunch of that output to make it easier to read. Like a bit of judicious use of capitals will also just help it. Okay, let's shorten a bunch of this stuff down. So we, let's have a look. So I'm keen to work out what the actual expected program time is, because we know at the moment this is as slow as a wet week. Expected program time equals %d sec. So we know CFI data OX2A minus 4. So that's the page size. So if we say 1048576, so if 1 megabyte divided by that times by the other thing is in microseconds, right? So this is going to give us a big fat answer in microseconds, which is going to be ugly big, I reckon. Let's first put it in microseconds per byte. So there's our microseconds divided by CFI data OX2A take 4. Okay, let's have a look at that. Yes, okay. So it should be about 1 microsecond per byte, which means, in theory, that we can program at about a megabyte a second. We're instead programming at about a megabyte a minute. For a variety of reasons. Okay, so let's just finish tidying up some more of this output. So got that, yep. And then we've got a bunch of this. general blather about it, which I'm just going to inset in so that we can see that it's general blather. Just make it easier for the eyes to scan down and find stuff. Right. It's still not perfect, but it's at least we can see what's going on a bit more here. Okay. Right. We can then choose and say we want to to flash that. Verify that it matches and should be safe. Yep. Okay. And now we wait forever. So remember on that display it was saying that the sectors should erase at about 256 milliseconds a sector. And this is clearly not doing it at that speed. So that says that we've got a bunch of overhead, and we know we've got a bunch of overhead. The other thing is that the data sectors are actually 64 kilobytes. But we're being very conservative in assuming that the sectors might be only 4 kilobytes. So we should be able to in our erase slot, where is it? Erase sector. So when we reflash this slot, we try and erase the sector. And then we're saying, so it's... okay. Now it is faster. Weird. But I still think that we can do larger erasers. Okay, so some of our delay is because we are verifying that the sector has been erased. Okay, right. Okay. So we're being all very good and sensible here. When we do the erasing, we're actually checking each sector to see if it's been erased, and if it hasn't been erased, then we're erasing it. And so this is actually doing the right thing. It's dynamically using the correct erase size for whichever sector it's on, because on these flashes some of the sectors can be 4K and then the rest of them are 64K in different kind of zones on the thing. So this is a good approach. What slows it down is that our read data function is as slow as a wet week. So it's still erasing because, and I need to fix the progress bar, right? Because it's it's erased nearly 5 meg now, and the progress bar is really tiny. So I need to fix the scaling on that. That's fairly straightforward to do. So let's have a look at our read data function while we're here. Come on, here it is. Okay, so we can see that we are doing a bunch of low-level SPI magic. And we transmit the bytes. There's latency code that says we have to send the equivalent of a certain number of bytes before we actually receive the data. That's all fine. And then we read the data. And again, this is more bit bashing, as we'll see. QSPI RX byte. Now, on the upside, when we read the data back, we're actually doing it with the there's a 4-bit method that we can use, which is good. But we can see we're having to bit bash this stuff, right? So if, for example, we poke OXD020, so we'll make it so that the border is white while it's reading, and then it goes black back again after. So we're going to interrupt our program again. Okay, almost any key to continue. We choose the thing, we press that. So we can see we have patches where the, I'll try and catch one, because I've got, in theory I can freeze frame the yeah, no, it's going to be a pain in the bum, but I'll try and freeze it so we can see. But we can see that it's taking about a frame to do the read, and then this loop is quite tight, right? So it's, whoops, oh come on, oh, that might work better. Wow, sweet. Okay. So it's taking, looking at that, a little over 1 raster line to read a byte. Now these are the physical raster lines, not the VIC2 raster lines. So it's 32 microseconds to read a byte. So that means to read the entire slot is going to take of the order of 32 seconds per megabyte. So just to do the erase check, just to read to make sure that we've erased every sector, is going to take minutes. So any optimization that we can do on this will be really, really helpful. So I'll unfreeze that, come back to our code. Right, now what's our delay? What is this delay function doing? Okay, now so it's doing nothing, but I will almost bet that the CC65 won't be optimizing out that empty function. So I am going to, the QSPI RX byte. So we're going to take that out and let's see if that helps to speed it up a bit. Now, some of these fixes that we do will actually be able to be carried across to the regular MEGA65 flash program as well, which will be great. I can already see there's a change in the character of this, right? It hasn't made a huge difference, but it has made some. Because I reckon it was putting a JSR and an RTS in for each of those. So where the real advantage is to be had with this is if we move to hardware accelerated SPI stuff. We've also got a for loop here, which I'll bet is also horribly inefficient in CC65. Actually, we'll go back and I'll put a freeze frame on. Yeah, so we can see now that it's taking. So it must have been, we had those offsets, right? So it was a little bit more than a raster line, and now it's almost exactly a raster line. So that's what we need to be. So what I want to do now, that's right, that's what I was going to do. Oops. What's that? This makes me mildly. Right, okay, that's at least that's not anything. Right, so we're doing that every byte. Why am I setting B? Again, CC65 is so stupid, even though the variable is up here, defined to be 0, I'll bet it's actually setting it. And let's just unroll this loop that runs twice, because it's just stupid to have a for loop. And if we do that, we can actually just say that. Look at that. Nice optimization. Because we didn't need to shift it on that occasion. Okay. So let's see how much that can help us. So again, we know the first few are slow for reasons that we don't really understand. That's okay, because it's only a few seconds that it adds to it. Although it would still be nice to find out what on earth it's doing at that point. And then it will hopefully, well, again, we can already see that that pattern has changed somewhat. Actually makes me, while we wait for that to get to the bit where it goes fast enough that we can see what's going on easily. We actually don't need to initialize B, and we can get rid of I. because we're initializing B down here. Right, okay, now we've got to the fast bit. Right, so now that's actually made quite a difference. Getting rid of that for loop, we can actually see, if you look on just under the screen where the border starts, there's actually 2 black bars on the same raster line. So we've almost doubled the speed, in fact, at which that it can do that, which is nice. And I think we have more fairly easy improvement that we can do, because again, at the moment, we're calling this routine, and almost certainly, that we are sorry, CC65 it won't be inlining the function, right? It will be calling it directly. So if one and it's probably doing some horrible thing with the argument passing as well, right? So now we are unrolling, sorry, we're inlining rather that function. Okay, and again, we'll have the slow bit to begin with. Already looking quite a bit faster. So I guess really what we want to be able to do is actually to have a hardware accelerated thing that lets us read a 512 byte region of the QSPI flash. That will tremendously accelerate this erasing stage. We also need to find out why these first bunches of pages read so darn slow. I need to find out what it's doing in that time. Again, we can see that we've got a quite pleasing speed. I'm just going to try and get it to get one where we can easily see. Again, when it's under that bottom border, it just makes it so much easier for us to get a measure of the time. There we go. Right, so now we've got 3 instead of 2 on a single raster line, but we're still taking, some number of microseconds to read each byte. Hey, happy doofish. So yeah, it's getting faster, and these are definitely improvements that we should put into MEGAFlash if they will fit. But again, I think what I really need to do is just to make the hardware accelerated QSPI flash reading and then writing. Because what we want is for it to spend as little time as possible on the reading before it does the erase. And it's a bit interesting again if we're looking at it. So the erases are taking time. It's a bit, frankly, a little bit suspicious that it still thinks it needs to erase them. Given that we've gone through and erased this just before, and we haven't actually fully flashed the slot again. So I'm actually going to right, blop, blop, blop. Let's have a look and see what it's actually read back. So we read data. Slot empty check. Because it's somewhere there where we're doing the erase sector, right? So we read the data. And then we try erase it. So what I'm going to do, just so that we can see what's going on here, L copy the data at address to go down about 10 lines, I reckon. So we should be able to see what it thinks it's reading, because it might be that it's reading gobbledygook. Yeah, so it thinks it's reading stuff in there, which is a bit interesting, given that we'd expect it to be empty after. So when you erase flash, by the way, it goes to FFs. So we shouldn't keep seeing this stuff in there. We should be seeing all Fs. What I'm going to do yeah, because we're only printing it when it fails, right? So we're not seeing the ones that already are clear. Yes, does make me suspicious that something is not being handled correctly. Also, just for so we can see what's going on more easily. So when we're erasing a sector, let's go. Make the border red while we're erasing a sector. Interesting. So I'm just wanting to see. Yeah, so it waits until the status flag clears. So that's all good. Yeah, so we're seeing it's taking a long time to erase those sectors, which is kind of what we expect, right? But why it thinks, because we just erased them when we ran it the last time, right? So these sectors should jolly well be empty. The only thing that noticed here, so we've got these erase commands, and so command 21 is supposed to be the erase command for 4K sectors. So I don't know whether it might be that we're doing something crazy where it's trying to erase the sector with the wrong command, and as a result it's stacked slower than it should be. Yes, that would be the case apparently. And then we get to a certain point where then that command doesn't work anymore because it's the wrong size sector. Okay, so there's some magic there that we need to, we can speed things up quite a bit. Actually, you know, that's actually really interesting. I can see the ROM version of a C65 ROM there, the V920228. That shouldn't be in the flash. I don't know where that's getting that from. So which just adds credence to my whole theory that there's something really messed up with the flash erasing. But where that can be getting that from, because the Mega Flash program, right, reads out the list of cores out of the flash. It's actually reading from the flash. And it reads it correctly and goes, yes, okay, yep, there's the correct labels in that. So that all actually works. Yes. So where the heck is it getting that from? There's something here that I don't know what's going on. See you, Herdware. Good to have you along. Yeah, that we need to try and understand. But that's also interesting that we can actually erase those 4K sectors much more quickly. So there is some of these flash chips have different zones on them with different size sectors. And so that information we should be able to work out. In fact, if we restart the program, sorry. Right, okay. So it says 4K parameter sectors. Let's have a look at some information about these QSPI flash chips. I think there's a suspension part. MEGA65 handbook will tell us what they are. Just need to have a look at the schematics. Okay, now it's one of these little chippies. No, that's a different one. Here it is. That's an S25 FL256. What did I say? S25 FL2. Yeah, that's the one. Right, data sheet. Right, yep, so this is the one that we've got. So we should be able to program it at up to 1.5 megabytes a second. And we should be able to erase at up to about 0.5 megabyte a second. Okay. Hybrid sector size option. Physical set of 32 4KB sectors at the top or the bottom of address space, with the remaining being 64K. So this is what it's doing. And there is a way to find out where those are. And so yeah, the sector arrays on the 4K sectors is slower. That's fine. We totally can live with that, as long as we know. Okay, so the sectors are a hybrid combination, and we know it's a hybrid combination, right? Okay, and it looks like it's based on the device model. And does it say anything about the hybrid? Keep jumping through to find it. Because I think there's a register that lets us read it out. Devices with a hybrid are initially shipped with the 4K sectors at the bottom of the array. Yes, so we've seen that. But the device configuration, CR12, bit 2, can be programmed to invert this. The CFR geometry above table is okay, yeah. The flash device driver must examine the TB palm bit to determine if, yes, okay, that's fine. Okay. So it might be that TB palm is what we need. erase block region 1 information. .3F, maybe that's related to it. Okay, we'll come back to that. I just want to keep looking for things about hybrid to see what it tells us. So we're expecting there to be 32 4K sectors. Okay, so now we can TB Palm. Okay, so we can find out whether the 4K physical sectors are at the top or at the bottom. That's good. What we want to do is to find out the number of 4K sectors. Ah, cool. Thanks, Leiden, for doing those messages, and I'll update those. So there has to be a way to get the thing. So if we know the size, actually, Detlef, have you got the exact part number that they're putting on for the new flash? So I think it's actually the other part that's listed in here. Super, that'll be great if you can dig that up for me, please. Cool. Okay, let's have a look. So SF. Whoops. So the new one, I think, is just uniform sectors. Yes, uniform 56K sectors. Down here it says. Whereas the one that we're using does it that way. So let me. So it has a uniform sector option. Page programming 512 bytes is the fastest way to do it. Okay, yeah. Erasing. That's interesting. Oh, so the page programming, that's why. So the erasing is 256. Okay, right, so it's just... Okay, we just have to detect the part family number thing. So we've got device ID. Read the device identification. I want to see what it thinks it's responding. So we've got 0219. So this data sheet is not for the correct thing. Either that or we need to add one to both of those, which is a bit weird because that otherwise would make sense. So the manufacturer ID is that, and then the device ID. So what I'm looking at is here, right? So we've got our manufacturer ID is 01 and the device ID is 0219. So what's the new one going to respond with? Right. So the 512 megabit one, which I shouldn't have on my board, looks like what my board is reporting, but it can't be right because try and have a look at our when you pull the device ID. Okay, so we get, so we're doing command 9F, manufacturer ID, device ID, and the other part of the device ID. Okay, let's, yes, because we're using a different device ID thing. So that's the one that we're using. Read ID command. Okay. The device, a byte of manufacturer identification, 2 bytes of device ID, extended device identification, CFI will be shifted sequentially out on SO. See page 44 for the detailed information. Right. Okay. There is useful information here. So that second device ID byte actually tells us the flash size. So the 19 is for 256 meg. Okay. And then we can read out how many more bytes come. Aha, and this is what I want to know. What is the sector architecture? And we're already, okay, so we're reading that out, so 4K parameter, yes, okay, that's good. So what we want to know is how many of those. So this is the ID CFI. Where's my mouse gone? Ah, that's not what I'm trying to do. Come on. silly thing. Right, so this is the one that we have. Okay, so we can tell that it's 4K. Yes, and so we're already reading that information out. So we know it has 4K parameter sectors. What I want to know is, does it tell us how many of them it has? Yeah, so this is where we're reading all of that timing stuff out, right? Device size. Yep, which you can read out again. Aha. Erase block 1 region information. So this is how many sectors there are of that size. So byte 2D. Okay, right, so we've got the CFI data. Okay, so this is now making much more sense as to where we're at. And we take away 4 because we've read 4 bytes early. That explains that -4. So what we want to know is how many sectors we have. So it's 2D -4. So we've got the parameter sectors. If that, okay. %D times 4 kilobyte sectors. CFI data OX2D, was it? Yes, 2D -4. Okay, let's $31, yes, because you add 1 on to it, I think it said. Yes, so you have to add 1. So, with that information, so if it's uniform sectors, then we say num 4K sectors equals 0. Num 4K sectors equals 1 plus CFI data OX 2D take 4. Okay, so right. If address shifted down by 12 is greater than or equal to the num 4K sectors, do fast 4K sector arrays, do 64 kilobyte / 256 kilobyte sector arrays. So this should be faster from the outset, and then it shouldn't bomb. Yes. So that's certainly better. And that should work with the new chip, because it should just know that the new chip is just all big stuff. So now the mystery to me though still is, why are we reading rubbish? There's still something quite mad going on there. Might actually try and run good old Mega Flash. Ah, yes. So I need to, because it's designed to exit by default, I need to hold down the no scroll key. Oh, I can't press it too quickly, right? Okay, I'm just going to have to time this because I have to get past it in there. Ah, yep, that's still too early. Because otherwise the loaded bit stream is correctly saying that this is not our first boot and won't drop. Right, there we go. Okay, so this version is clearly a bit bonkers in that it thinks we've got 8 slots. That's okay, I don't care. Because what I want to do now, flash inspector, was it? Where's our keyboard input? Because there was a nice little routine in here. Ah, flash monitor M. Ha ha! Right. Notice that it appears to all contain Fs, which is correct. It does, because we've been erasing them. So, quite why we are reading something else in our other one is a little mystery for us to solve. So let's have a look back at JTAG Flash. So when we do read data, we give it a start address and we put it into data buffer. Actually, you know what, let's do, instead of doing that, let's run the monitor from in here, because I saw it. Flash inspector. There it is. Let's see if the flash inspector can read it correctly, because it might be right. Yes. So that's correctly reading that it's erased. So we are doing something bonkers like reading from the SD card or something instead. Okay, so we start trying to erase. We read the data at that address. We're dumping that to the screen. We're using the read data routine in there as well. So the read data routine should work. Let's make sure we're reading the right address on here. Oops. Okay, yes, sorry, our flash inspector is reading the right data. I just messed up what I was trying to do. So we actually do want to pretend we're going to reflash the slot, because that's where we've got the... We're displaying what we've got there, while, and I'll make it wait for a key press each time. I love the hardware accelerated keyboard input on the MEGA65. It makes it so much easier to do this kind of thing where you just want to check if there's a key press, right? Just being able to read a register, and then to be able to clear the key out. So we pretend we're going to flash. Right, so it's claiming that at that address there is that data. Whereas when we're doing it in the flash inspector, which calls the exact same routine, we're getting something else. And I can also see 38911 in there, so this looks like we're reading the ROM instead of from the flash. But the funny thing is that the ROM isn't written in the flash that I'm aware of. It's something weird. Yeah, see, it looks like I'm reading RAM. That's indeed what it looks like. But it shouldn't be the case, because we're reading from there. We're printing out. Let's make sure we print out the whole in case, because I think adder will be along. Yes. Let's just make sure we're not doing something stupid like reading from some multiple of the size of the flash or something. Nope, we're still reading from address 0. 10 seconds. Okay, so I need to figure out what's going on there. This is interesting. So I've just been stepping through, and there is something else. So it doesn't look like it's out of the ROM. It is reading. Actually, yeah, let me just check what's. Yeah, we are just reading RAM, so Detlef, I think, is right. So why data buffer? Yes, we are indeed showing the contents of RAM, even if it's actually correct. Right. So let's do that again. Good. Right, now it looks better. But notice we're still erasing it, even though it's clearly full of FF. So there's a logic bug causing it to erase things when they don't need to be. So I'm going to check and see what I ends up. Because if I is 512, we should skip the erasing and just try and read the next one. Aha, I is equal to 0. How is that coming about? That would be how it's coming about. Right, that would be a grand case of the stupids. Right, so now we're not unnecessarily erasing things. This is good. And so now the erase phase should now go through really fast. Limited only by how long it takes to read the data, because it's not erasing anything. And indeed it is. And because we've sped up that reading routine somewhat, it's much, much less annoying. But again, we can speed that up quite a bit more, because if we hardware accelerate the reading of that SPI data, instead of it taking, because what's it taking there? We're getting 512 bytes in about 3 lots of 512 bytes a frame, right? So we're getting 1500 bytes a frame, give or take. Whereas we should be able to get 10 times that fairly readily, without any much trouble at all. So I think what I need to do next is actually to do that SPI hardware acceleration. I'll have to have a think about how I do that, but I need to head off and do some other stuff now because it's morning, the family's up. Yeah, but that's still a pleasing step forward. I'm going to let this sit there and do the the writing, and again we can accelerate the writing quite a bit as well. But just getting that erase time down, we've sped it up tremendously in all cases now. That will be really, really good. And again, we'll backport these changes into the internal Mega Flash in the machines. As I say, if I get the faster reading and the faster writing, I'll just make operations that hardware accelerate, reading and writing 512 byte blocks, probably push them into the sector buffer of the SD card interface, and grab them and stash them from there. And yeah, that should then make it bucket loads faster. In theory, I think we actually should be able to reflash a bit stream within 1 to 2 minutes, something like that, instead of the 15 or so at the moment. And of course, this will be great for trends for doing the prep. So anyway, I'll let that chug away. I'm going to disappear now and get on with the day. Good to catch up with you all, and we'll see you next time.